Number 17. Four masses M, we have four of them, are arranged at the vertices of a tetrahedron of side length A. What's the gravitational potential energy of this arrangement? The arrangement indicates our tetrahedron shape. And let me first draw the first mass. So we have mass here. Let me make it bigger. And we have, okay, before I introduce another mass, by itself there is no potential, gravitational potential energy. However, once I introduce another mass, the equal mass, you form a gravitational potential energy that attract each other given the length A here. So the formula for the gravitational potential energy is PE equal negative, because it's more stable if they attract each other, so they lose the energy by attracting. So G times M times another M, because we have an equal mass. Had it been like a different mass, let's say the small m with a big M with a bigger mass, then we would have something like this. This would be the potential energy of two different mass. However, we have the same mass, so eventually this will become m squared. So A stands for the length between them. Alright, so this can simplify as negative G m squared over A. But we have three more mass that form the tetrahedral shape. So I'm gonna have another m here. And that length, okay, I know it's not perfect drawing, but you get the idea that length of each side here is going to be A. So how many do we have? How many potential energy do we have now just on this surface, bottom surface? We have three of these potential energy, right? It attracts, the mass attracts with this one, and that one with this one. So in other words, if I call this 1, 2, 3, so now I have a three potential energy that forms between or among these masses. However, I have the fourth mass that forms a full trigonal, the tetrahedral shape on the top. This time I'm introducing three A's, the distance A. So I have A, A, A. So I have total 6 potential energy, gravitational potential energy that attract one another in this system. So in this system I have 6 of these PE. So that just reduced down to negative 6 G m squared over A. So the answer has to be D.